Hello everyone, welcome back to the series of DSA for placement purpose. If you are targeting for product based company, then this series will definitely help you because in this series, in every session, we are solving the problem from product based companies. And not only we are taking the problem from product based company, but also we are covering the basics with the help of a quiz. Every session, we are taking a quiz from a particular topic and covering all the important basic questions from that particular topic. For example, today we will cover the important questions from recursion with the help of a quiz. So, basic learning is also happening in every session, and as well as we are solving the product based company problem. So, both things we are doing in every session, and so this will definitely help you. This series will definitely help you if you are targeting for product based company, maybe today or maybe after 2 years or maybe after 5 years. Definitely you need to think about the product based company, and this series will definitely will help you to land in your dream company. So DSA is okay, one thing which is required to get placed in product based company. Another subject which is also asked in product based company is the system design. So if you have one year experience, 2 year experience, then product based company will ask you question from system design also. Okay, so both DSA and system design are very important, and I'm happy to announce you that okay, iNeuron is coming up with a new course on DSA plus system design, which is covered from basics to very advanced level. Means if you are a complete newbie, then you can enroll in this course, and after completion of this course, you will feel like okay, you know so much DSA and system design. You will be ready for the any interview from any product based company after completion of that course. Let me share my screen with you, and let me share that course with you people. Okay, so for this course you can go to the iNeuron AI website. I hope that is visible to you. So please confirm in the chat section if I'm properly audible or not, and this is properly visible, screen is properly visible. I'm showing you okay, the course launched by iNeuron, DSA plus system design. DSA is required for first round, second round, or third round. Till third round, DSA is required for any product based company. You are going for any role, first round will be DSA only. And after that, okay, if you have 1 year experience, 2 year experience, even right now, the product based companies are asking the system design question from freshers also. So if even you're a fresher or 1 year experience, 2 year experience, 3 year experience, you will be requiring system design also. This course will definitely help you. You can access this course by going to the iNeuron.ai in the courses in bootcamp and in DSA, and you can click on system plus DSA plus system design. This course is complete practical course actually. Each and every session you will be solving the problem from product based company. Actual problem asked in interview will be solved in every class, every single class. Okay, every single class will be important, that will help you to make you ready for product based company. Okay, so this course is really really very important if you really want to go to your dream company or product based company. And we are covering in very detail from basics to very advanced, complete DSA and complete system design. Okay, so you can check out the detail on about this course, and you can go to this particular page. You will find out all the details, and if you will check out, see, if I'm going through one topic, if I'm going through like this array topic, you can see that okay, we are starting from very basic introduction to array, but doesn't mean that okay, we are not going in very detail. We are see different type of problems we are covering, like two pointer, sliding window, cadence, prefix, sum. And we are so in every session we are solving the man company problems. Every session you will be get ready for the product based company. Okay, so this the same way system design will also go, like DSA is going, and this course will be uh, is enough to crack any product based company. Okay, so you can check out the detail about this course on iNeuron.ai website. going to the courses, going to the boot camp, DSA, and system design. Fine, okay. Now I'm going with the today's session. Okay. So before moving on, once again, please confirm me if I'm properly audible or not, and the screen is properly visible or not. Please confirm so that we can move on. So this is our seventh session actually in this series. Seventh session. Although this session is independent of previous sessions, if you want to access the previous sessions, then you can go to the description, register for this course. This course is free of cost, and you will also get certificate if you will complete this course, and you will get benefited. The important part is that you will get benefited from this course. Why? Because you will be solving product based company problem in every session, and your basics will be clear in every session with the help of quiz. Okay, fine, okay. All the resources will also be provided if you will register for this course. Fine, okay. Today we will cover the recursion, which is one of the most important concept. Recursion without without recursion, DSA is I don't think is complete. This is one of the most important topic in DSA. Recursion. People usually find it difficult, but if you get habit to use the recursion, then you will find it you will find recursion very interesting, easy also. Okay, because writing the code with the help of recursion is more concise, and you can write more concise and accurate code. Concise, I have to use the word concise code you can write using recursion, which is easy to read by other programmers also. So recursion is preferred by the industry. Okay, for example, if you are solving a problem, there is two people. First person is solving the problem using loop, and the second person is solving the problem using recursion, and both have solved the problem very right way. One is using loop, one is using recursion. Then company will prefer the person who have write the code in recursion. Okay, company will prefer this person. Why? The reason is that this code is more concise and more easy to understand, which is very important, which is very important to maintain any software. Thus the code should be easy to understand, and recursion help us to write the more concise and easy to understand codes as compared to loop. This is the misconception that okay, loop based codes are more efficient than recursion, or recursion based codes are more efficient than loops. No, recursion based code may take more time even than the loop based code. Okay, so or maybe they may take equal time or maybe less time. Okay, so this depend upon problem to problem. Some problem recursive codes take more time, and in some problem loop based programs take more time. So complexity of the program do not depend upon loop or recursion. Okay, that depend on type of problem, not loop or recursion. The only reason recursion is preferred is it's easy to understand. Okay, writing the code in recursion, this become easy to understand by next programmers which will be joining the company. Okay, even I can say that okay, recursive programs take more extra space. They take extra space complexity of recursive code is more as compared to loop based code. Loop based code take less space as compared to recursive code, because CPU need to maintain the all the record of the recursive functions, and this all record is maintained in a stack by the CPU. So this stack space is the extra space taken by the recursive codes. So recursive codes even take extra space, but still they are preferred as compared to loop based code. And the reason is the code is clear, concise if you are writing it using recursion. Fine. Okay. So let's start with the one interesting problem related to recursion. Today we will solve one problem that is from Microsoft, and that is very popular problem. We will solve one problem from recursion, and we will after that, okay, after solving one mang problem, okay, so we will solve mang problem, and then we will take a quiz from recursion. This is what we are doing in every session. We are solving the mang problem, from a particular topic, and we are solving the a quiz also. The quiz is having most important question from this from particular topic. Today, the questions will be from the recursion. Okay, so we will take the quiz also, and we will before that we will solve a Mang problem. We will try to make the problem easy to understand. Okay, so definitely the session will help you to prepare for the Mang company, because we are solving the Mang problem as well as we are covering a quiz which is covering important questions from the recursion. Okay, and if you are scoring good in the quiz, you will also get a cash reward. Cash reward is also there in every session. So if you are performing good in the quiz, you can participate and you can check out, okay, how much you know about the recursion. Although questions are basics but are important, questions will be basic but important to build your to check your base. Okay, if you have the base in recursion or not. Okay, fine. Okay, so two things we will do today. Again, in every session we are doing the same thing. We are solving the Mang problem, and second thing is we are covering the quiz, which is covering important questions from that particular topic. Fine. Okay, let's start with today's problem. Mang problem from recursion, which we will solve using the recursion. So this is the series plan. We have already taken 6 classes. If you want to take these classes, then you can register yourself for this course. Today is the 7th day. We are covering the recursion. After that, we will cover the problem related to searching, sorting, linked list, hashing, stack, queue, tree, binary search tree, graph, greedy, dynamic. You can see all the important topics of DSA will be covered in this series. Let's start with the recursion today. Before moving on, okay, with this problem, please let me know if I'm properly audible or not. Okay, people are replying. Hi Hassan, nice to see you back. Good afternoon. Hello Dream. Great. Okay, fine. You are talking about what does recursion is. Is it for recurrent? No, it's not related to the. It's not related to the. Hassan, it's not related to the machine learning. Okay, recursion is one of the important topic in DSA. Recursion means, for example, if you are calling a function, here is a function. You're calling the same function from inside. Okay, you're calling this same function from inside. So this is known as recursion. This concept is known as recursion. So if we are calling the same function from inside this function, then calling the same function from inside of the function is known as recursion. That's it. Okay, so we use this concept to solve many problems. Today we will solve a problem which is very famous one, Tower of Hanoi. Even you don't know, you can join the session and you can just take it as a game, and you can try to answer this question. Okay, it's a really interesting game. So actually, let me tell you about the game. The game is like this. We have 3 towers. Okay, there is a one mythological story also. Like we have, we have 3 towers, like left tower, middle tower, and the right tower. Okay, try to answer this question. We have some plates over here. So like one big plate, some small plates. This is big, smaller than that, then smaller than that. So for example, we have 3 plates over here, or we need to transfer these plates from left tower to the right tower using the middle tower. Okay, so this is the problem. We need to transfer these plates from left tower to the right tower using the middle tower in minimum number of moves. In minimum number of move, and there are some conditions also when we are transferring these disc or plates, whatever you can call. So like we cannot put a big disk over the small disk. Okay, this is not allowed. Putting the big disk over the small disk is not allowed. And second thing is, okay, no longer disk. Okay, first thing is this. Second thing is only one disk can be moved at a time. One disk can be moved from one tower to another tower at a time. Okay, and we cannot only top disk of the tower can be moved. Only top disk can be moved. Okay, you cannot move this disk until unless there is a disk over it. Fine. So the question is simple. We have some disk with us like disk 1, disk 2, disk 3, and we need to transfer this disk from left tower to the right tower using the middle tower. And this is the condition we need to follow, these three conditions. At one time we can move one disk only, and we cannot put the bigger disk on the smaller disk while transferring it from left to right. So in how many minimum number of moves we can transfer the disk from this tower left tower to the right tower? How many minimum number of moves? Minimum. So if you understand the question, and then can you tell me, okay, let's suppose we have number of disk, let's suppose is one. If you have one disk only, then in how many moves you will be able to transfer the disk from left to right tower using the middle tower? If you have one disk only, in how many moves you can transfer this disk from left to right? You need to follow these three conditions. You need to follow these three conditions. While transferring, you need to find out minimum number of move. Minimum number of move to transfer the disk from left tower to the right tower. You may use the middle tower. If you want, you can use the middle tower. But you need to follow these three conditions. Can you tell me, okay, in the chat section, if number of disk is one, then in how many moves you can transfer this disk to the right tower? In how many moves you can transfer? If anybody can reply. So this is the very popular question actually related to recursion. We will try to make it easy. Okay. Main Hassan says that, okay, let me check out in my mobile. Hassan says that two Ranker stock says that one. Okay, Hassan, why two moves are required over here? If with single move we can transfer the disk. Okay, this disk you can take this disk from here and you can transfer it over here. That's it directly. Directly we can put it over here. Directly we can put this disk from here to here. Okay, so if we have one disk, we can directly take it from here. One disk we can move, yes, and there is no other disk, so simply pick it from here, from this tower, and put it over here. Okay, so with single disk you can transfer in single move. Okay, and what if you have two disk? What if you have two disk? In how many moves you can transfer two disk? If anybody can reply, let's see. In how many move you can transfer two disk from left tower to the right tower? Let's see how many people can reply this thing. Let's see how many people can reply this thing. Two disk you have on this tower, left tower, and you, by following these rules, in how many minimum number of moves you can, transfer this disk over here? Hassan, Ranker Talk, or anyone else? So Ranker Talk and Hassan is saying three. Yes, you people are right. Because first you need to transfer the disk from left to first this smaller disk. Okay, let me erase it and write it again. This is our left tower, middle tower, right tower. Now we have two disks, one of size 2, let's suppose, one of size 1. So first what we can do, we can transfer this one from here to here. So left to right we can transfer, and then we can transfer this second disk from left to middle. So left to middle we can transfer. Okay. No, rather than doing like this, this is not the right way. What we can do, we can transfer this first disk over here in the middle. First transfer the first disk to the middle, and then transfer the second disk over to the right, and after that, okay, transfer this disk over here. So middle to right. Three moves we need to take. Three moves we can transfer the disk. Yes. So okay, now Hassan, you are okay for everyone. For everyone now, the question is: let's suppose number of disk are three. Number of disk are three, and in how many minimum number of moves? Minimum number of moves you can transfer the three disk from left tower to right tower. With how many minimum number of moves you can transfer the disk from left tower to right tower. So let me draw it. Three, two, one. Three disks are there, and you want to transfer it to the left tower to the right tower using the mid. You can use the middle tower. So can you give me the four move? If Hassan is saying four move, can you give me the four moves? What will be those four move? Narayana says that Uday Kumar says that five. Uday is saying five. Actually, that is more than four moves are required. More than five moves are required. Uday. So the person who will give me the right answer for this question, let's see. The person who will give me the right answer for this question, that will get a prize from my side today. Okay, that will get a prize from my side. Let's see who will give me the right answer. This is not the right answer. Four is not the right answer. Five is not the right answer. My question is, I'm repeating the question. The question, I'm repeating the question. Everybody can answer this question actually. Everybody can answer this question. The question is like this. You have three towers with you, left tower, middle tower, and right tower. You need to transfer three disks from left tower to the right tower. Okay. This is the condition you need to follow. These three rules you need to follow. Means you can transfer one disk at a time, and you cannot put bigger disk over smaller disk. Like you cannot put two over one. You cannot put three over one or two. You cannot put like this. Yes, you can put three, then two, then one. So you need to transfer these three disks from left tower to right tower. You can use the middle tower to perform middle any operation. You need to follow these three rules. With following three rules, in how many minimum number of steps you can move three disks from here to here? Six is wrong answer. Let me see. Okay, uh, I think no, six is also wrong. Ranker stock six is also wrong. Okay, Uday is giving some answer. One, two, three, four. One, two, three, four, five. Five is wrong. Six is wrong. Four is wrong. You can give me the moves. Okay, like Uday has given me the move. Minimum number of moves. How much required? See, if okay, Ranker stock is giving the answer. So let's see. See how. Let me tell you. Okay, let me follow the rule. Let me follow what you people will say. Let me take from the Uday. What Uday is saying, I'm taking that answer. Uday is saying move from left to right. I'm writing the Uday's move first. Left to middle again. Okay. Left to R and middle to R. I'm just taking Uday answer. If you have your answer, you people can also share. So let's see. Uday have given one, two, three, four, five moves. So let's see if this is working fine or not. Left to middle. Okay, I'm taking from left and moving to the middle. Again, left to middle. You cannot put Uday one over two over the one. No larger disk above smaller disk we can put. We cannot put the larger disk over the smaller disk. This is not allowed. Okay, this is not allowed. Think over again. You need to follow these three rules. You need to follow three rules. Ranker stock says seven. Ranker stock says seven. Yes, seven is the right answer actually. Seven is the right answer. Seven moves are required. Minimum seven moves are required to transfer three disks from left tower to the right tower. Minimum 7 moves are required. So, okay, one prize goes to Ranker stock. I will keep asking the question, you keep answering it. So, okay, let's see what are those 7 moves. So, Ranker stock is giving to us. Let me write them directly. Left to right. Let's check if he's giving right or wrong. Left to again, left to right. This will not work. Left to right, two cannot be moves. If you are moving one from here to here, you cannot move two from one to two because two cannot be placed over the one. No larger disk can be placed over the smaller. No larger disk can be placed over the smaller. Although 7 is the right answer, but sequence is wrong. Ranker stock. Sequence is wrong. Your sequence is wrong. Let's see if anybody can give the right answer. I have a prize for him who will give the right answer to this question to me. I have a prize for him. At the end of session, you will get the 100% you will get the prize. Can you give me answer of this question? You have 3 disks with you. You need to transfer these 3 disks from left tower to right tower. From left tower to right tower. You can use the middle tower. And you need to follow these 3 rules. What are the rules? You can transfer one disk at a time. You cannot put the larger disk over the smaller. You can put smaller over the larger. Okay. And you cannot take all the disk together. One by one you need to take. So in how many minimum number of move you can transfer 3 disks from left tower to right tower? Okay, Uday is saying that, sir, can you please tell, will L tower has disk in size manner from big to small as stack? Yes, right now L tower, Uday, L tower have disk like this. Biggest disk, then smaller disk, then smaller disk. Like let's suppose the size of this disk is 1, the size of this disk is 2, the size of this disk is 3. Okay, let me show you over the internet. I'm going over there and I'm writing tower of Hanoi, and I'm taking some images. Okay, so for example, you can see, let me show you with the help of a GIF. So here is the, I think you can, this is the 4 disk we have. Maybe we get with the 3 disk. So here is the 3 disk. Okay, it's so with 3 disks, I'm just checking. Okay, this is one. You can see over here. So you can see over here. We need to transfer the disk from A tower to C tower like this. Yes, Ranker stock, you are right. 7 moves we can make. Okay, let me go to the, let me write the answer now. Let me write the answer. So here is the left tower. Here is the middle tower. Let's see what is the answer. Here is the right tower. So we have 3 disk. One is size 3, one is size 2, one is size 1 over here on the left tower. So first we can, what we can do, what first we can move, I can move from, you people check out this will work or not. Left to, okay, left to right, then left to middle, okay, and then right to middle, okay, and after this I will do left to right, and after this okay, middle to left, and middle to right, and left to right. Yes, these will be the seven moves. These will be the seven moves that will be requiring to transfer these three disks from left tower to right tower. Let's see, is this working or not? So I take one in the first move and move it to the right. Fine, okay. Then we take from one, two from here and move to the middle. Fine, okay. And after that, right to middle, right to middle. So we take this from here and put it over here. Fine. After that, okay, left to right. So these three I have taken from here and put it over here. I can put because there is no disk on the right tower. After this, okay, middle to right, middle to okay, middle to left, sorry, middle to left. So I will take this one and put it over here. And after that, middle to right. So I will take this two and put it over here. And after that, we will take this last, left to right. So yes, we transfer the three disk from left to right tower, and we follow these rules. We do not put. You can see everywhere. We do not put the larger disk over the smaller disk. Okay, while doing this. So seven steps minimum required actually. Seven steps minimum required to transfer the three discs from here to here. Okay, one more chance I want to give you people. One winner with us is the ranker stock. Let's see if there is another winner. Let's suppose you have four number of discs. Let's suppose you have four number of discs. Then how many minimum moves are required? I have a prize for you people. If you can give me the right answer, I will give you the prize. Actually, this problem I have. This problem is also given in uh, in our mythology, also Indian mythology, in which if you can transfer according to mythology, if you can transfer 64, there was three towers, this tower, left tower, middle tower, right tower, and the ancient saints say that okay, this is just a story. 64 golden plates are here. 64 golden plates are here. 64 golden plates are here, and you need to transfer all these plates from left tower to right tower. If you can transfer 64 plates in your lifetime, if you can transfer 64 golden plates in your lifetime from this tower to this tower, then the the world will end actually. The world will end if you can transfer 64 golden plates from this tower to this tower. Then but you need to follow these rules. The rules is that you can transfer one plate at a time. You can transfer one plate at a time, and this do not happens till today. Till today nobody remains successful to transfer only 64 plates from left tower to the right tower. On copy pen also you cannot do. On copy pen also you cannot do. You cannot transfer the 64 plates by using these rules from left tower to right tower. Okay, why I am saying this thing? That is actually there is a scientific reason behind this. You to transfer 64 plates from here to here by using these rules, this will be requiring this much time, order of 2 power 64 time, order of 2 power 64 time. If let's suppose I'm writing in seconds, if this much seconds are required, do you know how much time is this? 2 power 64 seconds. Do you know how much time is this? If let's suppose you are to solve this problem, the time complexity to solve this problem, I will share the time complexity. Okay, we will discuss in more detail. I will write the code for this, and I will tell you the time complexity also. We will drive the time complexity, but the time complexity, okay, right now I'm telling you for this problem is 2 power n. Okay, and if n value is 64, let's suppose we are taking in seconds time. Okay, then how much time is this? Do you know how much time is this? Can anybody guess? Okay, how much time is this? 2 power 64. Any guess? How much time is this? 2 power 64. 2 power 64 seconds. How much time is this? Any idea? Any rough idea? Any rough idea if you have? Anybody? Any rough idea? Uday, Renkastock, Dream Big, Hassan, anyone? Any rough idea? How much time is this? 2 power 64 seconds. 1 hour, 2 hour, 10 hour, 20 hour, 100 hours. How much time is this? Any idea? Any idea, you people? You rough idea? Any rough idea you can give? Actually, this is even actually this. If I'm giving n value as 64 actually to my program to solve this problem, which is taking this much time to power n, actually that program will not stop. Jatin says that 1 lakh years. So Jatin, your life will end, my life will also end, even Earth life will also end. Okay, but this program will not stop. But this problem will not be get solved. Even my life will end, your life will end, even Earth life will also end. But this problem will not be solved. So actually, uh, this was in mythology, okay, Indian mythology, that okay, 64 plates you cannot transfer from one tower to another tower if we are following this rule. So actually they are right. Somehow they are right, because this is requiring this much time. 2 power n. 2 power n is 2 power 64 is actually even this is more than the Earth life. It's more than the Earth life. Okay, fine. Okay, so let's try to solve this problem now. Let's move back to this problem, starting from very beginning, and let's go through this problem. So the problem is simple. They provide us three towers: left tower, middle tower, and right tower. We need to transfer the disk from left tower to the right tower, such that we can transfer only one disk at a time, and we cannot put the smaller disk over the larger disk. We cannot put larger disk over the smaller disk. Larger disk cannot be put over the smaller disk while transferring the disk from left tower to right tower. So if number of disk is one, then only one move is sufficient. I will pick the disk from here and directly will transfer it over here. So if number of disk is one, then number of moves required is actually one only. Okay, and if number of disk is two, for example, one is of size 1, 2, one is of size 1, then how many moves are required? So what I can do, I can transfer this disk over here in the middle, and then I can transfer this 2 over here, and then I can transfer this disk over here. So three moves are required actually. Three moves are required. Let me write: left to the middle, and then left to the right, and then middle to the right. So three moves are required. And when n is equal to 3, number of disks are 3. Number of disks are 3. How many moves are required actually? How many moves are required? So let me write them again. So 7 moves are required actually. 7 moves are required. Okay. And which were the 7 moves? Let me write that also. So first, actually, how I was able to write the question, this solution, I was using a trick over here. Let me show you. I was using a trick over here. This trick we can use to solve this problem. Okay. Let me tell you the trick. What is the trick over here is that you can see that I just see the pattern over here when n number of disks were 2. What actually we were doing when number of disks were 2, then like 2 disks were there, then what I do, I transfer n minus disk over here first, n minus disk over here, and nth disk over here actually. Okay, means I transfer the disk 1 over here. So out of 2, n minus 1 I transfer over here, and then I transfer this 2 over here. And after that, okay, we can transfer the n minus 1 back to over here. Means this disk over here. 3 steps I was taking: this one, and this one. So here we are taking, we can move in seven steps. Okay, I'm writing the 7 steps. The idea is like this. First, I will transfer the n minus disk. n minus 1 disk. So total number of disks are n, that is 3. N minus 1 is how much? N minus 1 is how much? That is 2. So first I will transfer. So what I'm doing is I'm transferring, let me write over here, n minus 1 disk from where to where? From left to middle tower. Okay. So first I will do this thing. Second thing, then one disk will be left over here. I will transfer this largest disk to the right tower directly. So we will transfer one disk from left to the right tower. Last step, what I will do, so n minus disk, I will pick from the middle and I will transfer it to the last tower, right tower. So actually, I have transferred n minus this to middle tower. Now I will pick it from the middle tower and I will transfer it to the right tower using the left tower. Okay, so this is the method actually I'm using. By using this method, I can solve any problem, any size problem. Here, the 3 size problem. Okay, let me write over here. Let me show you what I have done over here. So first step is first, second, third. First step is take n minus disk, n minus 1 disk, that is 2 disk, and transfer it over here. So let me erase and rewrite it so that you can visualize it. I'm writing it again so that you can visualize what I'm trying to do. So I will take n minus 1 disk from here, means 2 and 1 from, I have picked from here, and transfer it to the middle in first step. Okay, and after this I transfer these 3 from left to the right tower. See, in the second step, this is what we are doing, transferring one disk from left to right. So transfer 3 from here to here, fine. Okay, and after that n minus disk, this disk from the middle I pick and transfer it over here. Okay, this is what I will do. Okay, transferring the 2 disk, I already know how to transfer the 2 disk. 2 disk I can transfer by using these 3 steps. Okay, so I can write 3 steps. I can, so how many, if number of disks are 3, here I have transfer how many disk? N minus 1, 2 disk. So for transfer 2 disk, to transfer 2 disk, we have already solved this problem. We can transfer 2 disk in 3 steps. In 3 steps we can transfer 2 disk. Here also we are transferring 2 disk. So in how many steps we will transfer 2 disk? In 3 steps. 3 steps I will take here, 3 steps I will take here, and 1 step here. Total number of steps are 7. That's it. So if somebody asks me number of disk are 4, number of disk are 4, then in how many steps you will take? I will say I will do the same thing. First I will transfer n minus 1 disk from left to middle. This I will follow this only, this algorithm only. And second, then I will move one disk from left to the right. And third step I will transfer n minus 1 disk from middle to the right. Middle to the right. Now, if number of disks are 4, then first I will transfer the 3 disk. 3 disk from left to middle. To transfer 3 disk, we already know how many disks are required. 7 disks, 7 moves are required. So 7 moves require here, and n minus 1 is how much? 3. 4, n is 4. So to transfer 3 disk, how many moves are required? 7 moves are required. We already know this thing now. And this is one more move. So total number of moves required is 7. 7 plus 7 plus 1. That is 15 moves are required. If number of disks are 4, then in 15 moves, I can transfer 4 disks. I can transfer 4 disks from left tower to the right tower by using the middle tower. Okay. If number of disks are 4. Yes, dream big, you are right. Yes, Renker stop. 15 moves we can take. Similarly, you can calculate actually. Let me give you direct formula also, how you can find out this thing. Actually, you can directly also find out by just by writing this formula. You can write, okay, that will be 2 power, if number of disk minus 1, this much moves you will take actually. So let's see, if n value is 1, then 2 power 1 minus 1, yes, one move is required. If n value is 2, let me see this formula is working fine or not. 2 power n minus 2 power n minus 1. So n value is 3. 2 power 3 minus 1, that is 7. Yes. If sorry, here n value is 2, not 3 actually. So 2 power 2, 4 minus 1, that is 3. Yes. In 3 moves, we can transfer the 2 disk. And we can find out if 3 disk we have, then 2 power 3 minus 1, 7 moves are required. Yes. So this formula is working. This formula is working. With the help of this formula, we can directly find out in how many moves you can transfer the disk from left tower to the right tower using the middle tower. Okay. And by following these rules. Fine, okay. So let's try to solve this problem in the coding. In the coding, this is very easy to solve actually. So let me write the pseudo code for this first of all. This problem is known as Tower of Hanoi. Okay. Let's suppose you want to transfer n disk from left tower to right tower using middle tower. Okay. You want to transfer n disk from left tower to right tower using middle tower. Then if number of disk is greater than equal to 1, then we need to transfer the disk. Otherwise if number of disk is 0, then how many moves we will be required? Let me write, okay, number of moves. Let me write integer. I'm taking a variable who moves. Moves are in the starting, this variable value is 0. Okay. I'm counting how many moves are required. Okay. If I'm going inside this if statement, then number of disk is more than equal to 1. If number of disk are 0, then I will return number of moves, which is 0 itself. Okay. If I'm not going inside the if statement, I will simply I will return that if number of disks are 0, then no moves are required. And if otherwise, how we can solve this problem? Very easy, by using recursion. Actually, we can solve this problem. If you notice, I was performing 3 tasks. If you notice that to solve, if number of disks are 4, you can solve this problem easily if you know the solution of number of disk, three disk solution. If you know the solution of 3 disk, you can solve 4 disk problem. You can solve 3 disk problem easily if you know the solution of 2 disk problem. You can solve the 2 disk problem if you know the solution of 1 disk. Okay, so this problem can be solved using recursion, because the bigger problem can be solved using the smaller problems. Bigger problem can be solved using the smaller problem. So if somebody want to know how many moves are required for n disk, to solve n disk, we know that how we can find out. 3 steps are required. First step is, I'm writing over here, I will call this function again for n minus 1 disk. Okay, if you can tell me how many moves required for n minus 1 disk, I will tell you how many moves are required for n disk. Okay, so for n minus 1 disk, what I need to do. So first I will transfer the disk from left tower to the, if you remember, then we transfer the, out of n disk, we transfer the n minus 1 disk to the middle tower. Okay, nth disk will be transferred then from here to here. So largest disk we will transfer from left tower to the right tower. N minus disk, first we will transfer from left to middle. So left to middle we will transfer. Using the right tower, we will transfer n minus 1 disk. After doing this, transfer 1 disk from here to here. So okay, let me write. Simply directly write transfer left to right, 1 disk. And after that, this n minus 1 disk we need to transfer from here to here by using this as a middle tower. Okay, so tower of Hanoi, n minus 1 disk I will transfer from where? From middle tower to right tower using the left tower. That's it, done. So this is the solution to solve this problem. Recursive solution, you can see that we are calling this function 2 times. Okay, if somebody want to know the solution for n disk, I need to know the solution of n minus 1 disk. So I will transfer n minus 1 disk from left tower to the middle first, then middle to the right. Okay, and this is the largest disk, which nth disk we will transferring from left to right. Any doubt in this, you people can ask me. Any doubt here, please ask me the doubt. If okay, again I will give you one prize from my side in this session itself. Can you tell me? Can you tell me how much space complexity this code will take? Let's see how many people can reply. What is the space complexity for this? Time complexity I have already tell you, that is 2 power n, and that can be find out easily if you know the recurrence relation. So the recurrence relation for this problem is Tn equal to 2t n minus 1 plus 1. So this is the recurrence relation of tower of Hanoi. And if you will solve it, this will make a complete binary tree, and complete binary tree have 2 power n nodes in that. Okay, so this complete binary tree of height n have 2 power n nodes. So the time complexity for this code will be 2 power n. Okay, we will discuss in more detail after writing the code. But can you tell me, let's see if anybody can tell me, what is the space complexity for this code? What is the space complexity, if anybody can tell me? Let's see. Space complexity for this code. I'm writing this code, same code, into the, I'm writing this code over directly over here. So this is the problem. Let me share the problem link. You can solve it at your end also. So let me share this problem with you people. Here is the problem link. Utsavi, you are right. Great. Space complexity for this problem is order of n. Can you tell me why this taking n space? I'm not using any array, anything. Why this taking order of n space? You are right, order of n. The space complexity for this problem is order of n. Fine, okay, I'm writing the code, the what we have discussed. Here you can see that they provide us number of disk, that is n. We need to transfer the disk from tower to tower using the auxiliary tower. Okay, just give that different name, or you can change it if you don't remember. So this is the left tower, this is the right tower, this is the middle tower. Okay, middle tower. So if number of days, okay, we need to transfer number of moves we need to take. One thing is this is the output, and second thing, we need to print this thing. Every disk movement we need to print in this format. Okay, I'm writing the code over here now. So if number of disk is greater than equal to 1, then only we will solve this problem. If number of disk is 0, then output is 0 only. Okay, and here number of, we need to transfer total number of moves we need to take, total number of moves. So that I'm defining a variable moves, initializing with 0. So if I will return 0 only if n values less than 1. Okay, if number of disks are 0, then simply return the 0 only. So I return the moves, moves. Okay, I'm not going inside this if statement. Otherwise, I'm going to if statement if I have at least one disk with me. What I need to do, I will call this function again. So let me call this tower of Hanoi function. I will transfer n minus 1 disk, from where to where? From left tower to the middle tower. From left to the middle tower using the right tower. Okay, this is one step we need to do, and after that we are taking one move. We are transferring the disk from left tower to the right tower. Okay, So for that, okay, we need to print this statement: move disk one from road one to road two. So we need to print this thing. So I'm printing the same format I'm using what they have mentioned over here. So let me copy paste it. I'm just printing this thing, okay, because they ask us to print in this. So number of moves also I'm counting for after every step. So here I'm transferring from left to, I'm just taking, I'm making copy from here because this is what they asked us to print. Okay. So I'm just trying that. Okay, I'm just printing in the same format what they're asking. So we need to transfer from first left to the L to the, so left to the right we need to transfer. Okay, so left. Now I'm copying this statement. Control C, Control V, and we one disk we transfer from left to the right. Okay. So I just write this statement because they want us to print this statement as an output. You can see in the output. And this move is, I'm incrementing my moves also because this is also taking one move. So incrementing move. And after that, you know that we will move the, we'll transfer n minus one disk from middle to the right. So moves. If any doubt is coming over here, you can ask me, because if you will ask me the doubt, then this will be easy to explain the things much easier. So any doubt here, you can ask me. First, I transfer n minus one disk over here. I transfer. Let me write transfer transfer n minus one disk from left to middle using right tower. And here what we will do, we will transfer n minus one disk. Now the disk is at the middle. Okay, so take the disk from the middle, transfer disk n minus one disk from M to R using using left tower. Okay, so let me transfer from middle to right tower using left tower. Okay, so that's it. So let me sum up this. That's it. Actually, we have done, and we can submit this code and let's see if this is working fine or not. Please check the status of submission. I think we need to sum. Let me compile it. So let me copy this code because they are asking us to refresh this code, refresh this page. So I'm refreshing this page. We need to sign in over here. So okay, let me sign in. Okay, fine. Here is our code. Let me submit it now. I think there is some space problem over here. Okay, so this is to R I'm transferring. So this is the code in Python. From to we are transferring. Move disk from move disk L, not L, I think. Nth disk we need to transfer. So N from road L to R. Okay, let me try to. compile it. Yeah, it's working fine. So let me submit this code. Yeah, it's working fine. Okay, I'm going through this code once again for more clarity. Just let me take the writing pad, discard it. Let me take the open board so that I can write on the coding screen. So I'm going to the coding screen back now. Okay, I'm going through this code once again. Last time, simple. The idea here is that to transfer n disk from left tower to right tower using the middle tower, I will first transfer n minus 1 disk from left tower to middle tower, n minus 1 disk, and then nth disk, largest disk, I will transfer from left to right. So this is what we are doing. First, we are transferring n minus 1 disk from left tower to the middle tower using the right tower. Okay, so we are transferring n minus 1 disk from left to the middle, from left to the middle. Okay, and after that, okay, one move we are making to transfer the this largest disk from left to the right tower. Okay, so this is what we are doing. We are transferring one disk, largest disk, from here to here. After doing this n minus 1 disk we will transfer from middle to right. So yes, n minus 1 disk we are transferring from middle to right using the left tower, using the left tower. Okay, so this is what we are doing over here, and we are counting how many moves we are taking, and we are returning those number of moves. We need to print this statement also. That's why I just use the same format what was mentioned in the question. So I just take the same format actually. Okay, fine. Okay, so this is the Tower of Hanoi problem, very famous one. Any doubt you people can ask me. This is the code in C++ and this is in Java if you are a Java programmer. The same thing is here again, n minus 1 from left to middle, and then middle to n minus 1 disk from middle to right using the left. Okay, and this is the Python code. Same thing, just syntax is different. The time complexity for this is 2 power n. The reason is that, okay, let me show you in C++ code. We can find the time complexity by generating the recurrence relation. So how we write the recurrence relation? This function we can write as a tn. Okay, this is the recursive function we are calling, but what is the size of the input? Tn minus 1. This is again we are recursive function calling. This is tn minus 1. And how much time this code is taking to execute? Constant time. So how much? What is the recurrence relation? Tn is equal to tn minus 1, tn minus 1, that is 2tn minus 1 plus order of 1. So this is the recurrence relation. And if you will solve this recurrence relation, you can solve this using iterative method. And if you will solve it, or you will find that the complexity is 2 power n. Actually, this is making a, you can see that you are calling two functions. So like here is n, this is n minus 1 and n minus 1. Again you are calling n minus 2, n minus 2. Here also n minus 2, n minus 2. Again n minus 3, n minus 3, and so on. So this will keep going on. So this will be a complete tree actually. And the height of this complete tree is n. And this is a complete tree. So how many nodes will be there? 2 power n. So the time complexity for this recurrence relation is 2 power n. And space complexity for this code is actually order of n. Why? The reason is that, what is the reason? So for this recurrence recursive tree, actually one stack will be maintained by the cpu. Cpu will maintain a stack and maximum size of this stack will be n only, because the tree's height is n. That's why the size will depend upon the height of the tree. Maximum and different functions can be there in a stack at a time. Okay, so space complexity for this code will be order of n. Okay, and due to this internal stack which is maintained by the cpu, not by programmers, we do not declare any, we do not use any extra space in the code. Only one variable we are using. This extra space is taken by the CPU to maintain the recursive function calls. And the maximum size of this CPU stack will be n only. Okay, because the tree size will be n. Okay, because the tree size is n, so maximum size of the stack will also be n. Fine, okay. So that's it about this problem. Any doubt in this, you people can ask, you can write in the comment section. Any doubt coming to your mind? Otherwise, okay, let's now move to the second part of this session, that is the quiz part. In the quiz, we will be covering the basic questions related to recursion. Okay, so this will help you to build your base in recursion. If you are new to recursion, then you can participate in the quiz and you can check out, okay, how much basics you have in recursion. Okay, this quiz will help you to check that thing. And so let me share the link of this quiz with you people. Here is the link of this quiz. You can join it. So basic, the questions are important, but the questions are basics. Okay, so the quiz link is given in the description. You people can join it. In the chat section, you can click on the link and you can join the quiz. And if you will be the winner, then you will get a prize, cash prize right now. Everybody can try. The basic questions are there from the recursion. Everybody can try actually. The questions are very basic. Everybody come on, join it. If you will be the winner in the quiz, you will get a cash prize. And second benefit of the quiz is that all the basic important questions from recursions are covered. Basic recursive questions are covered. Basic questions from recursion topic. Okay. I'm starting it, just waiting for last 30 seconds. Waiting for last 30 seconds. Any doubt in the previous question, you can ask me, anybody. Waiting for last 30 seconds. Maybe other people will join us. Okay, fine. I'm starting it now. So let me start it. Come on, try it. Everybody keep trying. So Savi is here, Amit is here, Karthik is here, Annie is here, Ishi is here, Lancaster is here. Everybody try. are very basic, but okay, this is for building the base in Recursion. Okay, keep trying. This time Avitan Utsuri is doing at the top. Third one is Karthik, fourth one is Annie, then Nishit, then Karthik stop. Keep trying. Great Utsuri, great Amit. The questions are very basic. Keep trying, keep trying. Karthik, Utsuri, Amit. Annie is also here, Rishi is also here. Mainly three people are competing right now. Amit, Karthik, and Utsuri. Utsuri is second, Amit is Karthik is third, Utsuri and Amit are waiting. You every time you remain as a winner. This time they are beating you. Minus 14 minus. Yeah, minus 5. One person is here. Keep trying. Great. Amit and also we are doing great. Questions are easy. Right? Amit is new. I think both people have already done both Ishi and these people are attempting. Let's wait for some little more time. Okay, meanwhile, so okay, I think we have done. Right, the stock is done. So if you have done, please write it in the line chat. You have completed. I think dream big is the tempting. Like, okay, I think we have done. Dream. The people who have done, please write in the comment section. So I think I have to stop it now because right stock actually the time is already over. I think you can see the answer also. I'm stopping it. So the winner is Amit. Congratulations, Amit. Congratulations, Utsavi, and congratulations, Ranker Stock. So let's go. Let me go to the problems also. Let's see the problems. So and after that we will. I will transfer the reward. So Amit and Utsavi, okay, to both of you, I will transfer the reward today. So Amit is actually is Mitali. Fine, okay. Uh, Let me go through the questions. So okay, here is the first question. Let me go through it very fast. How does the recursive approach to solve a problem typically compare to iterative approach in terms of space complexity? Recursive take more space than the iterative due to the stack. Okay, so recursive approach. How does a recursive approach to solve a problem typically compare to iterative? So iterative take less space. Sorry, recursive approach is less space efficient. Yes, A is the right answer over here. Recursive approach is less space efficient as compared to iterative approach because recursive take stack space. Stack space is needed for recursion. Okay, I don't know about the time complexity. Time complexity of both can be equal, or maybe recursive code may take more time or less time than iterative. Okay, time complexity we cannot compare, that depend upon the problem to problem. But one thing is sure, recursive approach take extra space due to the stack than the iterative approach. Okay, this thing we know. So A is the right answer. So recursive approach are less space efficient. They are less space efficient. Okay. The second question is, what is the time complexity of following function? So what the time complexity of this function is actually 2 power n, that is C. Okay, so two recursive functions are here. One is of n minus 1, one is of n minus 2. This is the code of the Fibonacci series actually. In Fibonacci series, using recursion take 2 power n time. Using loop, that take order of n time. What is that? What will be the output of the following code? The output for this one is the actually this will sum up the values 1 to 4. So 10 is the right answer. And next one is what is tail recursion? If the recursive function is the last statement, what is tail recursion? What is tail recursion? If the recursive statement is the last execution statement, then that is known as the recursive function. A recursive function where the recursive call is the last executed statement. For example, if I'm this is a function, I write some code over here and I call this function, and this is the last statement in this code, last statement, then this is the tail recursion. This is known as tail recursion. We know that our compiler can optimize the tail recursive codes. Okay, so we have, if we are writing the tail recursive codes, then compiler will optimize them. So it's better to write the tail recursive codes. Okay, fine. Okay, next one is What is the main advantage of using recursion over iteration? Recursions are actually faster and recursion are not faster. Recursion are actually recursive codes are often shorter and more intuitive. The codes recursive codes are shorter and intuitive. They are not faster. They are not easy to debug. They do not consume less memory. B is the right answer. They are easy to understand. They are more intuitive. Which data structure we use internally to implement the recursion? Stack data structure. We mean CPU take care of that. Which of the following problem is typically solved using recursion? Tree traversal is most famous problem. Uh, we traverse the tree using the recursion. Okay, this become easy to traverse the tree using recursion. So tree traversal is the one application of the uh, recursion. In a recursive solution, which can excessive function can lead to stack overflow. If we are calling again and again and again, then maybe stack memory get full. Okay, maybe we forget to write the base condition. Then stack overflow will happen. Stack space will be overflowed. Stack every recursive program take the stack space to maintain the previous functions. What will be the output of the following code? If you will check out this code, the output will be 10. What is the benefit of studying DSA and system design? Both are required for any product-based company. First three rounds will be from DSA, next two rounds will be from system design. So till the 5 year at least, even if you want to join as SD1, SD2, SD3, then you cannot skip these two subjects, DSA and system design. And you can check out this course uh, on iNeuron website. Okay, iNeuron is coming up with the DSA plus system design course, and you can go to the courses boot camp. In the boot camp, you can go to the DSA part. In DSA, you can go to DSA and system design course. So this course is you will not regret in your life, because this is covering each and everything in very detail from basic to advanced, and with the lots of practice questions. Okay, you will not regret. This is confirmed. Every session of this course is very useful, that will help you to get placed in your product based company, in any product based company actually. Every session we will be solving the practical problems only. Fine. Okay, next problem is, that's it actually. These were the questions. So uh, let me transfer the reward to our today's winner. One is Utsavi and one is Amit. So let me stop sharing my screen so that I can see the contact number of these two people in the. So Utsavi, will you please confirm your last two digit, please? I have transferred you earlier also. So let me check out Google form. Give me a minute. And okay. So here is the Amit contact number. So let me transfer to Amit. So done to Amit. Amit, please confirm at your end. I have transferred the amount. I have transferred the amount. Confirm. Okay, and now it's time for Utsavi. 64 it at the end. Yeah, Utsavi, I have already transferred you earlier also. Yeah, I get your number. So let me transfer to you also. Today you have really done great. So Utsavi also I have transferred. Please both of you confirm in the chat section that okay you have received. I think this is not visible. This is now visible. Please confirm, Otsvi and Amit, please confirm if you have received your reward or not. Please confirm. Do you receive or not? Yes or no? So kindly confirm at least, and then you can leave the session. I hope you get it. I have transferred it from my end, and that's it for today. Okay, that's it for today. I hope you like the session. If you like it, then give a thumbs up. And if you have any question related to the session, you can write later on after the session also. I will take the question in the comment section. Fine, fine. Okay, great. So I'm ending this session at my end now.